Hello, welcome to 3.4. We've got some book strategies for solving exponential and logarithmic equations. You are welcome to take a look at those. We're going to go ahead and get started. I'm going to have my own little take on it as usual, and whatever works for you. So the first set of problems, some of these problems are problems that would be really nice to solve without graphing. However, in your future, probably solving using graphing calculator or some type of software is probably at least as important as being able to do by hand. So we actually are going to do all these by graphing. So it says use graphing calculator to graph f and g in the same viewing window, approximate the point of intersection of f and g, and then solve f and g algebraically. So we'll come back, we'll talk about that a little bit, but believe me, we're going to be solving some things algebraically. So here we go, 27 to the x. Nice big exponential function, and 9, and why not zoom standard? We're graphing those two, and here comes that first function, just explodes, and the second one, well, that makes sense. The intersection has to be up at 9 because this function's always 9. That might help us realize that when we graph 18, we might want a little different window setting for this, but I'm going to show you an alternative to that as well. So now I'm going to go second calc intersect, and I just want to get, I'm on the blue curve, I just want to get close to that intersection and hit enter. It jumps me onto the red curve close to the intersection, enter one more time, and 0.6666666, it looks like probably x. Now you can round that to 3 decimals, but I believe x equals 2/3. So to represent that, I mean, think about this one for a second. By the time we put in 1, we're all the way up to 27. This goes through 0, 1. It's absolutely flat till it gets really, well, close to absolutely flat there. And it exits before we even get to 1. 7, 8, 9. We got another graph, goes right through here. And that's just so I know that you actually use your graphing calculator for it. Now, alternatively, we could, I noticed 9 and 27 are both powers of 3. I could write this as 3 squared equals 3 to the 3rd to the x, but that's 3 to the 3x. And if 3 squared equals 3 to the 3x, then 3x must equal 2. X equals 2/3. Okay, now for this problem, I could graph this, graph 13, and then go ahead and try to zoom and find the graph. I know it's going to be up at 13 where these intersect. Alternatively, watch this on 16. Had I done this instead, this is my favorite way to solve equations with the graphing calculator. I just take one function, 27 to the x, and I subtract the other equation from it, minus 9. I graph that, and I want to know, if we want to know when 27 to the x equals 9, well, 27 to the x minus 9 would equal 0. I want to know when this graph right here, when this function crosses 0. So I go second calc 0, stay to the left, enter, get to the right, enter, and sure enough, same solution. And then I don't have to look up, down. I'm only looking for where the graph crosses 0. So on 18, which I'm not going to solve by hand, it's not the worst problem in the world to solve by hand, believe me. 18, I'm going to go ahead and just do this with the graphing calculator. We're going to get plenty of practice solving problems by hand. So here we go. Y equals clear 2 to the negative x plus 1 minus 3, and then I subtract the 13. And now I want to know when that hits the axis. So I'm really graphing, let's say h of x is 2 to the negative x plus 1 minus 3 minus 13. You can simplify that if you want, but that's really just to show what my graph is. So we graph that, looking for where it crosses 0. Looks like it happens at negative 3. So we got a graph that appears something like that. Now, I don't have a whole lot of points of accuracy there, but that's the point we're looking for. Let's confirm. You got two options here. We could go second calc 0, just like we did on this previous problem on the calculator. Or if you think you know, you could go second calc value negative 3, and sure enough, negative 3 is a 0. X equals negative 3. Now we could set these equal to 0, or excuse me, set these equal to each other, add 3 to both sides, and you see when I add 3 to this equation, I get 16, and now I have a power of 2. So we could certainly do that. All right, but I'm absolutely fine with you doing it this way. This page I'm really concerned with that we can do this with our calculator. Okay, y equals clear 3 log base alpha window log base 5 of x, subtract the second function minus 6, and now graph. I'm in Zoom Standard. Okay, so I suspect it might hit 0 somewhere down the road, but I see that's flattening out, so I'm going to go to Window and maybe change this to 50. Let's see if that's enough. My X max. And yep, 50 is enough. So second calc intersect. Make sure you stay to the left of the 0. Look, my y is negative here. All right, getting pretty close. So I'm going to stamp enter there. Step over it till the y is positive. Hit enter, enter, and we get. Oh, you know what? I think I don't think I did the right thing. Second calc 0. Did I do intersection? Okay. All right. I am to the left of it now. I am to the right of it now, and we get 25. So I suspect this wouldn't be too bad. Number 20, excuse me. I suspect it wouldn't be too bad of a problem. Here's my y equals. In case I didn't bring that into focus, we've got 3 log 5x minus 6. We graphed it, and we found out, just putting it all together here. So we've got a graph. I don't know what the scale is here, but or what scale we should use, because we found out second calc 0 again. We found out that our 0 was at 25. So I'm just going to put 5, 10, 15, 25. 25 right there. Don't let me down, pen. So we look something like that. So x equals 25. And you can see that if I was to set these equal to each other, I could divide both sides by 3. I would get log base 5 of x equals 6 divided by 3 equals 2. This is the exponent that turns 5 into x. This is the exponent that turns 5 to x, but this is 2. So 2 is the exponent that turns 5 into x. X equals 25. Okay? Again, but we're specializing in the graphing. Okay, this one actually is remarkably easy if you understand logarithms, but we may not quite be at that state, so I'm going to talk through that one in just a moment, but let's go ahead and graph it. Clear ln e to the, that's second ln, e to the x minus 2. That's not what I want. Yeah, that's fine. Step out of that. I need to subtract all of 3x plus 2. There's our likely mistake that we might make. Just put minus 3x plus 2 minus all of 3x plus 2. And let's go back to zoom 6 on this and see what we got. Actually, looks like a straight line goes through that intercept, this intercept. That seems somewhat surprising with a logarithm, perhaps. It looks like we have a 0 at negative 2. Let's check it. Second, calc value. Let's go value negative 2. Yep, negative 2 is our 0. X equals negative 2. So if we were to do this one by hand, take a look at this right here. That is log base e of e to the x minus 2. A great way to read it, a terrible way to think about it. This whole thing, this big mess right here, is the exponent that turns e into e to the x minus 2. What is the exponent that turns e into e to the x minus 2? X minus 2. I want to know when x minus 2 equals 3x plus 2. Subtract x. Subtract 2, and x equals negative 2. See, e to the and ln and natural log, those are inverse functions. So actually this simplifies really nicely. But hopefully we're leaving that page comfortable with our calculator. And stay tuned. Let me know if I can help you.